Here's an explanation for the answer to final exam question 100 in Electronics Demystified 2nd edition. Please see page 439 at the bottom. We're asked about different amplifier types here. Which one of them conducts current for the smallest proportion of the input signal waveform? Is it class A, AB1, AB2, B, or C? And I have drawn diagrams here of the situations for class A, class B, and class C operation. In class A operation, output current flows in the collector or drain or plate part of the circuit for 100% of the input cycle. We have here on the vertical axis relative current, here time going from left to right. Class B, current flows for half of the cycle. Class AB1 and AB2 are intermediary between these two situations. In Class C, current flows for less than half of the cycle. And the reason for that is that the device is biased well beyond pinch-off or cut-off, so that the input signal actually has to overcome a reverse bias before any current can even flow at all. So you get these pulses. Class B biased right at pinch-off or cut-off, so it in effect rectifies the signal, half-wave rectification along with amplification. Class A, you're biased so that the device conducts all the time. It's biased at a level considerably below the cutoff or pinch-off threshold. So the thing you want to avoid, though, with Class A operation, I should mention, is that you shouldn't drive the amplifier so hard that this lower trough here, this lower part of the signal, goes below this axis here, because if you try to do that, you're going to get it chopped off, and you are in effect going to get distortion. Class A operation is the least efficient, but it provides the best fidelity for things like audio. Class B is more efficient than Class A, and Class C is still more efficient than Class B. But again, the caveat with Class C is that you have to provide quite a lot of input power, driving power. But the correct choice here is E. It's in a Class C amplifier of the choices given that you get current for the smallest proportion of the cycle. Well, congratulations, you have finished this test. Now you can move on to some other book of mine, I hope. I hope that you have enjoyed yourself somewhat. I would like to conclude by offering a picture that might just inspire you a little bit. My ham radio station. There's the transceiver. There's the big 46-inch display that I purchased largely because I wanted something really cool in my ham radio shack to look at. There's a monitor that I use for displaying text primarily. There is an interface that makes the radio work with the computer. The computer is over here. The keyboard, antenna, standing wave ratio meter, and an amplifier here, an audio amplifier that provides a lot of sound, so that I've got surround sound here in my ham radio shack. If you're interested in ham radio, but you don't have a license yet, you can tune into my YouTube channel that has a bunch of videos. It's entitled Amateur Radio. And you can go to the ARRL.org website, American Radio Relay League. They have a lot of information about how to get licensed so that you can do this and communicate with people around the world with no infrastructure between you and them whatsoever. That's the cool thing about ham radio, that even if the entire internet went down, and even if the power grid went down, if you have a station like this with emergency power and somebody else on the other side of the world has a station like this with emergency power, you'll still be able to communicate They can't say that for the internet or for any other communications medium that relies on human intervention, as it were. So this is what you get with ham radio. A lot of cool stuff to look at, a lot of cool stuff to do. These are phase shift keyed signals displayed here on this screen. So with that, I will say so long from the Black Hills of South Dakota, United States of America. Until next time.